Okay, so we're going to go over 2.2 today, and the whole focus is using representations to model situations with linear and exponential functions and determine whether when a discrete model or a continuous model is most appropriate. And we've kind of talked a little bit about this, but I haven't necessarily like pinned down these words for you to make it super clear. So today is going to be that day. So questions you should be able to answer is, what's the difference between discrete and continuous? How can I tell if a discrete or continuous model is best? Are all linear functions continuous? Are all arithmetic sequences discrete? Are all exponential functions continuous versus discrete? And then the domain, which is something that will follow you all throughout. And it's kind of like that thing that at first, when you understand what domain is, it doesn't make sense until later. So if domain doesn't make sense to you, don't worry. It'll make more and more sense to you as kind of like you learn more and more about it, if that makes sense. Okay, so I'm going to skip the jumpstart problems just so that we can get into our launch, because it's a really good context for you to wrap your brain around those two concepts. So it says the Library of Congress in Washington, D.C. is considered the largest library in the world. They often receive boxes of books to be added to their collection. Since books can be quite heavy, they aren't shipped in big boxes. On average, each box contains 8 books. So if on average, each box contains 8 books, how many books are received by the library in 6 boxes, in 10 boxes, or in n boxes? So I already looked at your work, and your work looked really well. Your work looked really well. No, your work looked good. Sorry. Your work looked really good. So I'm going to kind of like grab a couple people's work here. So if you notice here, we have a couple people putting dots. And that's the very first thing that I noticed. And I'm like, hey, how come you guys aren't connecting the dots, right? And then I see in one box, this person, random person, has 8. In the next box, 2 boxes, it's 16. 3, it's 24. 4, it's 32. N is 8. And they said, this is my function here. So this is actually really fantastic. I'm going to take a picture of this whole thing. So that you can see this. So this is actually perfect. I'm going to copy this onto my notebook. This is my new thing lately. Not because I don't want to do it, mostly because you guys are doing such a fantastic job of doing this. Oh no, I didn't put this as a background. So I'll put this right here and I'll squeeze it a little smaller. The questions that you should be asking yourself are, hey, how come none of the pictures actually had the lines connected? And if you're comfortable with all this, the only one that I don't see the domain is what I want to talk about first. So over here, I'm going to talk about domain. So the domain of a function means this. Hold on, let me just change this to my font so you guys can all find it. What is domain? Anybody know what domain is? Let's change this. Oh no, my chat, it's not open. Yeah, right? Okay, so what is domain? I will say it like this. It is all of the possible x values that make sense for the x. Okay. What, Miss Johnson? What are you talking about? Okay, so let's look. This person used 1, 2, 3, 4, and so on for values of n. Can you tell me what numbers you all didn't see for you all didn't use? What kind of numbers did you not use for your domain here? What kinds of numbers did you not use? Yeah, we didn't use negatives, Miss Johnson. Oh, why not? And then you're like, oh, Miss Johnson, because you can't have a negative box. Exactly. So in this case, no negatives. What other kind of numbers did you not use? What other numbers did you not use? Yeah, we didn't use fractions. Oops, I should put no. So for this context, we did not include, we didn't include negatives, we didn't include fractions, we didn't include decimals, we didn't include square roots, right? We didn't say square root of 3 boxes, Miss Johnson. That doesn't make sense. Exactly. Okay, so do you see what I mean by it's all the possible X values that make sense for X? So no one told you, hey guys, don't use 2.4. You guys just kind of understood. So Miss Johnson, what would our domain then be? So our domain is a fancy, I'm going to put the fancy letter because then you guys can start using it. And then when you guys have me for in a couple of years, you'll be like, oh, Miss Johnson, you taught us that fancy letter. So this is a fancy N. It's going to show up. It means natural numbers. Natural numbers. So if I brought like a 4-year-old in here and I said, hey, can you count for me? And they're like, yeah. And I'd say, okay, count for me. What would they say? What numbers would they say? Yeah, they'd go 1, 2, 3, 4, 5, and so on. Okay, so as soon as this guy catches up, my iPad is not working today, but that's okay. So the fancy N has an extra stick. So eventually I will show you, but right now it is not showing you. So I'm just going to leave it alone. Oh, that's because I'm on number 2. I know why, because I'm up here. I found me. I was complaining and I found me. There you are. Okay, let's move this guy up here. Boop. Okay, so it's all the natural numbers. So it's all the numbers that you would have counted as a child. Okay, then you learn division, and then you learned more about fractions and decimals and so on and so forth. Okay, so is everybody comfortable with this here? Is anybody confused? Ms. Johnson, why didn't you connect these points? Why didn't I connect these points? Why did this person not connect them? Why did most of you not connect your points? Let's do that. Look at you. Look at all of you. You didn't connect your dots, right? For the most part, you didn't. Right? We didn't connect them because it doesn't make sense to connect them, right? Between, like this person's, between box 1 and box 2, between box 1 and box 2, do you have, like, I'm gonna mess up your thing, but it's not gonna mess up forever, so don't worry. Like, this is me trying to draw a straight line, I know. Are there all these points in between here to get to here? Like, is there a 1.5 boxes? Is there a 1.7 box? Is there a square root of 3 boxes? And everyone says no. So because there's not, then I can't connect those 2 dots. Does that make sense? Connecting these 2 points would imply what? There's a 1.7 box, a 1.3 box, right? And that doesn't make sense. It also implies that there's 10.2 books, right? No, I don't think so. Okay, so we're going to move on to the next context. Ms. Johnson. Okay. So the next part says, many of the books in the library are electronic. Everyone say, ooh, ooh. Okay. About 13 ebooks can be downloaded onto the computer each hour. Okay. 13 ebooks can be downloaded each hour. If 13 ebooks could be downloaded onto the computer each hour, how many ebooks can be added to the library in 3 hours, 5 hours, and n hours? So go ahead and start doing this because I saw some of you did not finish this one. So this is hours. I like how someone put n and then they put in parentheses hours. So they said how many could be added in 3 hours. So I'm going to start with 1 just because it helps me. And then I'm going to put 2, and then they asked for 3, and then I'm going to skip 4. I'm going to put 5, and then I'm going to put n down here. So can you fill this side out? How many ebooks can be filled out. And then I want you to ask yourself the question that we answered over here, which was, we couldn't connect the dots here. And then over here, my question is going to be, can we connect the dots here? Okay, so I'm going to pause. You're going to pause. You're going to fill this out really quick. I'll wait for you. Okay, so you all did a great job of filling in our table. So yeah, you guys did 113, 226, 339, and so on, 452. And some of you even put your n here as your function is 13n, and we got some dots here. You all said, again, we cannot connect these dots. Okay, so again, kind of. But can I ask a question? When something's downloading, right? Like think about the last thing you downloaded. It wasn't completely downloaded, but what did it tell you? What did it tell you as it was downloading? Yeah, it told you how much of that book was finished downloading, correct? So what do you think? Should we connect the dots here? Yeah. Should we connect the dots here for the downloading books? Let's see what you guys said. Someone connected their dots. So I'm going to go with Alicia here. This is these are your mathematician names here. The answer is yes. You all are yelling at me in the chat right now, which is hilarious. Okay, not yelling, but yelling, funny yelling. So yeah, you should connect these dots. Ms. Johnson, why? Why should we connect these dots? Okay, so I'm going to pick orange, and I'm going to pick this little dot right here. Okay, and I'm going to pretend this little dot is, let's see, it's, I don't know, it's like 0.75 comma, and I should put parentheses, so give me a second, and it looks like, I don't know, like 18. Okay, so I'm going to pretend this point is exactly 0.7518. I don't know if that's right, so just ignore me if it is. Actually, I think it's wrong, right? Because one book is 13, so it can't be, but just pretend on this line. So now I want to make it right. Oh, Miss Johnson. What's 0.75 of 13? I don't care. It's 13. Let's just do 13 times 0.75. Sorry, we're going to just put that number in there. Miss Johnson, you put that in a, yeah, I can actually calculate it. Hold on, let me calculate for you guys. Bring my handy dandy calculator. 13 times 0.75, dun, 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 9.75. Ooh, okay. There you go. I'm going to put a 9.75 in there. Okay. If I told you, hey guys, I have 0.75 of an hour, does that make sense? Like if I said, hey guys, how much time do you need to work on this assignment? And you guys are like 0.75 of an hour, Miss Johnson. Would I understand what you're talking about? Yes. Yeah. Everyone's like, Miss Johnson, that's 45 minutes. Exactly. Okay. And I said, okay, if I gave you 0.75 of an hour to work on this assignment, could you get it done? And you're like, yes, Miss Johnson, I can get 9.75 problems finished. Okay. 9.75 problems kind of makes sense to me. It means you've completely answered 9 problems and you're almost finished with that last problem, that 10th problem. Does that make sense? So 9.75 books. Wait, what happened? I know there's a lot of chaos today. That's okay. Okay. So, hey, can I talk about, hey, Miss Johnson, how many books have you downloaded so far? Would you all look at me crazy if I said, hey, I got 9.75 books downloaded so far? Does that answer make sense? Yeah, that answer makes sense. Okay, let's go back. So I'm going to snip this one because I have already been talking about this one for a while. Oh, it's a little bit off. Hold on a second. Let me grab your scale is just a tad off. That's why I'm a little bit worried because you when you read this, make sure you're reading this. Do you see how this is 2? You said 2 was 26. And if I follow 2 all the way up, it's a little bit off. So fix your scale just a tad. Fix your scale a tad. 1 looks like 13-ish. 2 looks like 26-ish. Sure. Yeah, this one looks pretty good. Okay. So like, hey, Ms. Johnson, if I didn't connect the dots for this one, would it be wrong? Well, yeah, because they want you to come up with the correct answer. Okay, so let's go back here and let's like study. Why was this context connected? Why was, oh wow, it's like gigantic. Let me make this a tad smaller. Okay, so why was this context with the ebooks? Why do we need to connect the dots here? But why did you say, Ms. Johnson, don't connect the dots for our books? Now, if I said, hey, I have 9.75 books in this box right here, right? I have 9.75 books in this box. You all would think I was being funny, right? But it wouldn't make sense, right? And then some of you are like, but Miss Johnson, it kind of does make sense because like, what if my little brother tore out like the last part of the book? Okay, then I'm going to go back to the Library of Congress, which is a very prestigious, library. Would they accept that book? And then you all say, no, Miss Johnson, they wouldn't. So yes, 9.7 books, 5 books make sense in the physical sense. But in terms of this context, because we're going back to the Library of Congress, it kind of doesn't. So, oh my gosh, I know. I would get so like, my books, don't rip my books. I even have issue with like, how, I don't know, my teacher used to call it dog earring, like when you fold the page corner so that you can remember where you are. Like I have even issue with that. I know I'm a little silly, but that's okay. Okay, so the next little context I'm going to read, and then you guys I'm going to pause again, and then you guys are going to work on it. Okay, so the next little context says, the librarians work hard to keep the library orderly and put books back into their proper places after they've been used. A librarian can sort and shelf 3 books in a minute. If a librarian can sort and shelf 3 books in a minute, how many books can she do this in 3 hours, 5 hours, or n hours? Oh wait, this is a lot. Yeah. I want this to be a lot. You guys are so funny. Okay, yes? All right. So can you pause right now? And then I am going to come back with some good answers for you. Okay, so for this one, so we're considering the context that a librarian is shelving books at 3 books per minute, and you guys all had this conversation, and you decided that because she's shelving 3 books a minute, that means she's shelving 180 books per hour, right? So then that's 360 for 2 hours and so on and so forth. And then some people came up with this fancy expression, some fancy expression here. That's correct. Okay, and then we have this, like, we have a little bit of, I don't know, Miss Johnson, should we connect them? Should we not connect them? So the conversation that I want to have with you about connecting or not connecting is asking this question. I understand that I can have 0.75 of an hour. So that your X is fine. But what about for your Y? Can the librarian shelf or put away 9.75 books? 9.75 books. And most people said no, Miss Johnson, she cannot put 9.75. And some of you are like, but what if it's like halfway away? It's not put away, right? Like just clear that. So for this context here, we did not connect the dots. Okay. And some of you who like want to hold on to this argument and say, no, Miss Johnson, it's okay. Because this one, I can kind of see what you're saying in terms of putting away and not putting away the book. So here, I'd actually, for this context, I'm going to say I would accept not connecting and connecting at the same time. But do you see how here, this one was a very clear, yes, you'd have to connect it, right? And very clear here, no, you cannot connect them. So when you can't connect the dots, that context is called discrete. Remember from our vocabulary over here, we were talking about this word discrete. Oops, where did it go? Discrete. Discrete means like whole books. We can only talk about whole books. Continuous means I could talk about like 9.75 books. Okay, so just kind of keep that in mind. So here, we'll go back over here. Nope, we'll go back over here. Okay, so tell me which one this is. Is this called discrete or is this called continuous? Let me make this a tad bigger. Is this one here called discrete or continuous? Yeah, this is called discrete. Discrete. Why? Because the points are not connected. Okay. Very good. This is called discrete. Everybody okay with discrete? Yes, Ms. Johnson, I'm okay with discrete. So on a quiz, say, I don't know, pretty very soon. Pretty very soon is not really a word, but I will say, hey, is this, and I would just show you a picture of this. Is this an example of a discrete or continuous function? And you guys would be like, discrete. And then I would say, well, explain. And you would say something along the lines, because the points are not connected. Okay, because the points are not connected. Okay, this one then, the downloads, discrete or continuous? Yes, exactly. Oh my gosh, look, I don't even have to say anything. I love it. I'm going to erase. Oh, I'm just going to copy what this person said. I'm literally going to copy. I know it doesn't look like it, but I'm going to copy what your classmate said. That's what they said. And I'm just going to make it bigger. Can I make it bigger from here? Nope. Oop. Oh no, I forgot that C. That's all right. This is continuous because the points are connected. Continuous. Yeah, you did it. Did I spell something? Very good. Continuous, 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 continuous. Okay, so again, continuous. So I like to tell my students, this would be a good roller coaster track to ride on. This would be a bad roller coaster track to ride on. Got it? You guys are hilarious right now. Okay, so this one as well, I will clip this one in a little bit and put it on here. Okay, here's those questions that we were asking before. So it says, would it make sense in any of these situations to be a time where 32.5 books had been shipped, downloaded to the computer, or placed on the shelf? And we talked about this, right? And which of these situations represent a discrete function and which represent a continuous function? Okay. Okay. And then we got to this part. So give me a second.